Hi, yes, Evan. Today's lesson is on probability again, and this time we're going to be looking at experimental probability versus theoretical probability. So let's just get down some definitions in our book. Make sure you've got that title down. Theoretical probability is what should happen in theory. So the probability of something just in theory means that it hasn't actually happened. It's just what we would expect to happen. So, for example, the theoretical probability of getting a 6 on a dice is 1/6. So that in theory, every time you roll the dice 6 times, you should get 1/6. Now, where experimental probability comes in is that we know that in actual fact, every time you roll the dice, you're not going to get 1, 2, 3, 4, 5, and 6. Say you roll it 6 times, you're not going to get each of the numbers because in an experiment, something might change. The theory is just like something we can use to expect what we should get. But in actual fact, you could actually end up getting 6 6s, or you could end up getting 0 6s. It's not that likely that you would get 6 6s, but it can happen. So experimental probability is the probability as a result of an experiment. You might also see it called relative frequency. So frequency just means how many times something happens. So these two are used. They mean the same thing. Experimental probability and relative frequency mean the same thing. So don't be put off if you see relative frequency. So it's the probability of a result as an experiment of an experiment. Sorry, and sometimes it's the experimental probability is the only thing we can use. For example, with a dice, I know that there's 6 possible outcomes and one of those is a 6, so it's easy to get my theoretical probability. Whereas experimental might be, I might ask a question, and a question I'll go through later is, what's the probability that someone supports Man United? Well, I can't say, or I can say how many people there are, say, in the world, I don't know, or in the UK, let's say, and I could make a rough prediction, but I might carry out an experiment to see how many people that actually is. So I might go around and do a survey and say which football team do you support, and actually record a tally of how many people say Man United. So sometimes there's no theory to go on in that you don't know the total number of outcomes and you don't know the desired outcomes. So we need to carry out some sort of experiment. So I'm going to go through an example of a question that would use relative frequency or experimental probability now. Make sure you've got those two definitions down in your book. And the first one I'm going to use, or just a question, is what is the probability that a car is red? So that's my question. That's my question that I've been given. And I can't just say, well, there's this many cars, there's this many cars in the world, and this many are red. I can't just get a theory like I can with a dice. There's no theoretical probability to it. So what I'm going to do is carry out an experiment where I record the frequencies of a car of the colours of the cars. So let's say I go outside and I sit down by the side of the road and I'm just going to record the next 20 cars that come past. I'm going to record their colour. So Right, so let's just pretend they're coming past. So let's say the first one's grey, next one, well, let's say green, silver. Oh, there's a red one. Let's say there's another red one, yellow, black, black. Let's have white, silver again. So how many have I done? 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's have another red. Let's just do 10 for now, actually, just to make it a bit quicker. So I've then got, out of the 10 cars, how many of them are red? Well, out of the 10, 3 are red. So I can say the probability is 3/10 or 30% or 0.3. Now, obviously there are some problems with that. I've only tested 10 cars really, so it's quite hard to say, well, that is definitely the probability. So there's actually a way I can make my result more accurate. So to make a result more accurate, I can keep on doing my survey and get more cars. So the more cars I looked at, the more accurate my probability would be, because you're getting a bigger sample. So say I carried on, and then I noticed there was another red and another red, another red. Let's say 4 reds in a row. Another yellow, blue, blue, red, red, red. Now I've carried out 20, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 red cars. Let's just double check that. 1, 2, 3 from the first go. 1, 2, 3, 4, 5, 6, 7 from the second go. So I've got 10 out of 20 after doing 20 observations. So let's use my notation that we learned. Probability of red equals 10 over 20, which I know is a half, which could lead to 50%, or 0.5. Doesn't really matter what you put. And if a question was to ask which probability should you use, well, you should always use the more accurate one. So I'd use the one that's used more, where I've made more observations. Something else you might use experimental probability for is to compare it to the theory. So say I had heads or tails, then my theoretical probability is that if I get a heads, then it's a half. If I get tails, it's a half. Well, we know that, say I flip the coin 10 times, I'm not necessarily going to get 5 heads and 5 tails. I might, for example, get a sequence might go 1, 2, 3, 4, 5, 6, 7, 8. Might go like that, and I can see that my relative frequency or experimental probability is that to get a tail 1, 2, 3, 4, 5, 6. There I've got 6. So this is my theoretical one, and this is my experimental one. What you would find is, as you do more and more trials, so say I did 1,000 flips of the coin, then this probability would get closer and closer to a half. So this probability here would get closer and closer to a half, because the more trials you do, the more accurate it is. Right, I'm just gonna get you to do 2 questions. Oh yeah, no, I want to go through something else, and that is expected outcomes. So that might be where you've got a probability, and then you say, well, if I did it 1,000 times, what would I expect to get? So I'm gonna give you an example, and it's the one I mentioned earlier of what football team do you support? So let's say that's my question that I want to answer. Then I might go out in the street and I'll record my data. So let's put the best team in the world on there. The worst team in the world. And let's just do Arsenal, Man U, and other. So let's say I go out and I record my data, and I've got 20 Brighton fans, 0 Palace fans, obviously. Let's say 10 Arsenal fans. Let's say 12 Man U fans and 8 other. Then in total I asked 20, 30, 42, 50 people. So I know what my experimental probability is going to be out of. Then a question might be how, so this could be an example of a GCSE question, how many Brighton fans would you expect there to be in 1,000 people? So a group of 1,000 people using my data, how many would I expect there to be Brighton fans? Well, I can see that from my table, the probability of being a Brighton fan is 20 over 50, or 2/5. What I'm going to do to find out how many there would be in 1,000 is times my probability by times 1,000 by 2/5, because I'm finding 2/5 of 1,000. 2/5 of 1,000 is the same as doing 2 over 5 times 1,000. Well, that is 2,000 over 5, which gets you 400. And you can use a calculator for that. So 400 people I would expect to be Brighton fans. Right, there's one more question I'd like you to have a go at then. So make sure you've got that example down in your books. And then can you have a go at these questions in your book, pause the video, and then I'll go through the answers now. So, a triangular spinner has sections coloured white, green and blue. So I've got them labelled here, that's my spinner. It's spun 20 times, and the colour it lands on each time is recorded. So I've got an experiment here that someone's undertaking. Complete the relative frequency table. So first of all, they're out of 20. So I know my probabilities are all going to be out of 20. Now I need to record how many were white. So there's 1, 2, let's cross them off as I go. 3, 4, 5. So I've got 5. Green, 1, 2, 3, 4, 5, 6, 7, 8, 9. So then blues, well, how many should I have left? Even before counting them, I should. If I add 9 and 5, then I get 14. So I should have 6 blues, because in total there's 20. So let's just check that. 1, 2, 3, 4, 5, 6. Perfect. So I know I've got it right. Because remember, all these probabilities need to add to 1. Right, so there's my 2 marks for that. These are the relative frequency after the spinner is spun 100 times. So someone else has done it, but they've done it more times. And they got 21 out of 100, 52 out of 100, and 27 out of 100. Which of the 2 relative frequencies for white is the best estimate for the probability of the spinner landing on point white? Give a reason. Well, the second is. So we've answered which of the 2 is the best. Give a reason. Because the spinner has been spun more times, therefore it is more accurate. Remember, if there's more and more trials, you do it more and more times, then it's going to be more accurate. Just like in my last question, if I'd asked more people who they supported, then it would be more accurate. Or if I might have been standing outside Brighton Station, for example, and then it's obvious that most people are going to support Brighton around there. But if I had, say, went all around the country and found out who loads of people supported, then it would be more accurate because I found out more people. Right, the spinner continues to be spun. Estimate the number of times the colour blue will occur in 2,000 spins. Well, the first thing to do is I've got two probabilities for blue. Which one should I use? I should use the more accurate one. So the probability of blue after 2,000 spins is 27 over 100. And then we're estimating the number of times. So this is the expected outcome, 27 over 100 out of 2,000. So I'm saying what's 27 over 200 out of 2,000? That would be 54,000 over 100. So I would expect 540. And obviously you could use your calculator there. Let me just double check that. 2,000 by 54,000 over 100. Yeah, I'm happy with my answer of 540. So if it was spun 2,000 times, I would expect it to come up blue 540 times. Right, make sure you've marked that in red pen. You've got everything down from today's lesson. If you need any support with anything, email me. Have a great day.